This is Stephen Donner from Mozilla, and I'm on the Firefox test engineering team. And I'm here today to give you a high-level overview screencast, introducing you to and showing you some examples of the ZAP-CLI, which is a Z attack proxy command line interface tool, which is a Python wrapper around the Open Web Application Security Project, OWASP, open source Java-based web security and vulnerability scanning and reporting tool. The audience for my particular talk, and I guess the tool itself, is really anyone interested in a way, although there are multiple ways, of integrating a security scanning tool and a vulnerability testing tool and reporting against your web service, your web application, maybe some parts of your infrastructure in a continuous integration and deployment environment, either in like let's say a Jenkins pipeline or a workflow, or even just in Jenkins on an on-demand basis. The choice there, the flexibility, that's yours. So the audience for that really can include multiple sets of people, and that would be test engineers, developers, operations, security folks, but really anyone with interest in this tool or tools like it. I hope you find this useful. So the goal for this screencast, as I've mentioned, is really just to give a high-level overview. I've worked on this for a couple of quarters. I had to learn a bit of Docker, a bit of Jenkins, and quite a bit of at least the high-level parts of ZAP in order to bring these three things together. So, as I mentioned, I'm bringing ZAP, Jenkins, and Docker together. Thankfully, the Docker and the ZAP parts were brought together in a particular image inside of a container. So we do have some dependencies. My particular usage of this is a shell script which calls and pulls down a Docker image and then uses a Docker container to run the ZAP CLI inside of that container on a Jenkins instance. So you will have a GitHub dependency, or at least you can inline shell script if you want. Jenkins, you don't need any plugins for Jenkins, at least not specific to Docker or ZAP, thankfully. And you will need to have a pre-installed Docker instance, or daemon rather, on your host and have that talking to Jenkins. And why I chose Docker? Well, it's not just because it is, a great tool for kind of isolating and abstracting runtime for things that run on top of file systems and kernels, but it's also because it's more secure, it's more lightweight, it's portable. So let me just dive right into what is rather a very clean run against a production website using this script. So if I show you that, you can see here in the Jenkins, hopefully you've got some Jenkins familiarity. If not, you can Google some of this later. We're basically pulling down from my Docker-ZAP repo on GitHub. We are calling my shell script, which is the only script in that repo for now, against the host mozillians.org, which is a production site. And then from the ZAP instance itself, we get the information that ZAP is running, that it is loading this URL here, and it's running the spider less than 3 seconds later, or 3 seconds later. And then just a few seconds later, it's found 0 issues. So that is the part of output that is not from my shell script. That's just from the ZAP engine directly. And then the daemon log is something that I do output with a single command just into the Docker container, and that's followed here, and so that's in full. This is what a log looks like, quite a lot of information about the initialization and things that it's loading and things that it's trying. But really there's nothing here to pay attention to other than that there's 0 issues, so that's a good thing. So let me explain briefly a little bit about the script. Pretty simple, but it's doing some cool things. So first of all, it assigns a variable container ID, and it runs the Docker image called ZAP, which inside of it has a shell script inside of the Zap2 Docker weekly image. Docker-weekly container. So images are high level and then containers are within inside of a Docker image, if you're not familiar with that kind of breakdown. And before it does that, it runs as the Zap user, so that's the -u zap, the -p 2375, that is the port mapping, and it runs in the daemon mode. And it also runs not only the container itself in daemon mode, but it will start Zap itself on the host in the daemon mode, or attached to the daemon mode rather, on port 2375 on host 127.0.0.1, which on my particular DigitalOcean host is the local host or loopback. So I have some blog posts that I will show you later at the end of this that talk about why you want to run Docker on a local host and things like that. The other couple of important things to notice here, I don't have an API key for this particular instance, so I want to set that to disabled. And I do want both the attack on start and the view mode to be attack. These are recommended if you want your engine to run kind of at full strength against your test application. So then in line 6 here, I've got a target URL, just basically setting in the shell script to a variable, which I'll show you can override later in Jenkins. Then we do a bunch of executions against the container, which is hosting the ZAP-CLI, and we tell it to basically open the URL, which is the one that we're going to pass in. Then we will spider that URL, which will go through and discover JavaScript, regular HTML links, etc., even some CSS links in there. It will put them into its engine, and then it will start in line 12, kind of active scanning, which is not necessarily attacking, but in this case, it essentially functions as that. And we use -r, which is recursive. So not only is the first URL that we pass in as the target URL running against that, but all the other discovered URLs below that, the engine will find and also attack. And then the end in line 14, we've got a call to the ZAP-CLI to just call alerts, which basically anything that'll show up will show up in a nice HTML table with what I will show you later. So, and then just below here, line 17 through 26, we've got a divider, just basically very, very simple things to print out a dividing line, showing that there's the output of the scan engine itself, and then we show the logs of that, and then we also issue the stop command to the Docker container so that we don't have this long-lived, long-running Docker container around. So let me show you a run from something that did find something, and that would be Mozilla reps. So alazon.org is a staging instance for Mozilla reps, which is our community leadership program website. And according to this, and I actually need to investigate this, it says it's found 131 issues. If you look here, 2226, the alert, risk, CWE ID, and URL columns, those should be self-explanatory except for probably the CWE ID. So CWE stands for Common Weakness Enumeration IDs, and I've got a link to that here. So the CWE ID, and let me load that up right here, is basically it's an industry standard, and it's a way of categorizing web vulnerabilities or poor programming practices in web applications and web APIs. Standard set of terminology that people can understand and begin a discussion around and hopefully address when you're going through a web application. So then you'll see on the right, you've got the URL, and of course to the left you've got the alert type, the name of the alert, and then the risk high, and then or the risk severity rather, and then you've got again the URL. So you'll see there's a lot here. They're almost, I think they are actually all the same. The other thing to note about Docker, and particularly the ZAP-CLI that's inside of the Docker image, is that it all uses the same Java version, and that's because everything inside the Docker image is self-contained, including the memory size that it sets, the Java version, all of that. So you can take this from host to host. You can take it from SE Linux to Red Hat to CentOS to Ubuntu, even on a Mac, and this would still be the same. You'd basically have the same portability. Of course, if you have different processing types and things like that, you might have different constraints, but the actual engine itself and the way that it runs will be the same. So let me show you another one that has quite a few different ones, and that is demo.testfire.net. So this is actually another vendor called Watchfire. You'll see at the bottom here, Watchfire Corporation. They set this test site up, which is on and off available. So I happened to catch it at a time that it was available. It is basically a test bed for some parts of their and other vendors' applications scanning engines to kind of demonstrate both the capabilities and also the vulnerabilities of not only engines but web applications themselves. So I've used that one with their permission, and you can see it's got 21 issues. Again, you can see here there's different types. So there's SQL injections, there's cross-site scripting, there's anti-CSRF, and then of course you've got the same log file. Let me show you one more over here, which is TreeHerder. So TreeHerder is a Mozilla project basically showing you check-ins to the Mozilla code base, and I include this one just because it's kind of interesting. There is actually a CWE ID, which the number is 541, and for that it is source code disclosure. So in this case it happens to be Subversion, which is SVN. I'll highlight that here with my mouse, and that's saying that at this particular URL there is some source code that it thinks that it found. So that alerted on that. Of course, being an open source project, that is not actually a problem. That's a good thing. So I thought including that would be kind of humorous. But it's good to know that it does look for source code. So if you are a third-party, non-open source vendor, or you're open source but you're integrating commercial libraries and you want to see if those are exposed, this is a good thing to be running against. So there's a lot here. This is a very high-level overview. The things that this does not do, at least the way that I have it currently configured, it doesn't use cookies, it doesn't do authenticated sessions, it doesn't do a lot of the advanced scanning, and I haven't yet integrated specific parts of the core or the API in terms of add-ons. So the Zap project has the notion of add-ons, especially if you're using the GUI, and the add-ons are just like they sound. They're ways of integrating different open source and other library scanning engines and fuzzing engines and things like that. So if you've seen RSnake's XSS suite, things like that you could actually load in through that API, and I don't have those integrated here. So if you're interested in those, that's something that you should work with either myself or on your own, or with this gentleman here, Grunny, to get put back into the ZAP-CLI, or call maybe through the Java API that it wraps. So that is it. Hopefully you have some questions and a lot of interest. One second here, sorry. So here's a bunch of links. I've got a link to the Zap homepage. From there you can also easily find things like the ZAP-CLI. You can find a bunch of the other kind of forks or different aspects of the project. My email address is there. Also my GitHub repo with the specific Docker-ZAP files are there. And then I've got 4 of my blog posts which specifically talk about kind of my aims and the setup. And then at the end, one of the most kind of important and kind of real-time things, real-time-ish because there's a bunch of contributors who work in different time zones, as is par for the course in open source, is pound websec tools available on ircmozilla.org. And so I lurk in there I ask a lot of questions in there when I'm working on this, and depending on whether there's individuals around, I get answers either in real time or they answer when they come back online. So I hope this has been useful for you. Please do ask me questions, or other people in that channel questions, or file issues on my GitHub issues page or on the ZAP repo page itself. And thank you very much.